Hi, you guys. It is Coach Younger. I'm in the abandoned team room of the CHS Fieldhouse, and I'm wearing a hat because it's cold. So here's what we have for this week. Um, we kind of looked at dimensional analysis. I just call it PAL. We kind of looked at PAL when I was gone last week. We're gonna still be talking about PAL because it is very, very, very important for this semester. So here is all your notes. This is for the entire week. So again, you don't have to get these done on Monday. If you do, fantastic. You have plenty of time to work on your lab. But I'll be going through these with you guys so you have them. Alrighty, let's go ahead and get started. So, let's see. Flip and change or PAL. Really, all we're doing, we're converting one thing into another thing, right? So let's just do a quick practice problem. Like we did last week, I always recommend. Let me just make this full screen. What I always recommend is that you guys write what you're given and what the unknown is first, because basically you're gonna first start in the top left with what you're given, and you're going to the unknown using your conversion factors. So, for instance, how many seconds are in a day? This is really, really simple. All we do, we're going to start with seconds, right? Or we're going to start with days. You are given days, and you're unknown. What you need is seconds. So we're going to start. Let me say that again. We're using unknown and known. So what you know, you have days and you're trying to get to seconds. So a good conversion factor for these two things would be seconds per day. Okay, so here's our unit that we're trying to get to. Seconds per day. What do we know? Well, let's just start. Oh, is it not working? Hello, friend. Okay. So here we go. Sorry, guys. What do we know? There's 60 seconds in a minute, right? Another way to write that is 1 minute over 60 seconds. We also know that there's 60 minutes in 1 hour, right? Another way to write that, there's 1 hour in 60 minutes. So using these conversion factors, we're going to find how many seconds are in 1 day. We also know that 1 day is 24 hours. So using this, we're going to go from seconds to days. These are what are called conversion factors, where the numerator, the thing up top, and the thing on the bottom are going to be equal. So, for instance, 60 seconds equals 1 minute, right? They're equal to each other, so we can set them one up top, one on the bottom. All right, so let's just start with going from seconds to days. How many seconds are in a day? There we go. So we do know that there's 60 seconds in 1 minute. I don't know how many seconds in an entire day is off the top of my head, right? So we can start with 60 seconds and we have a minute. Now, the units we want to get to are up top. We want seconds per day. When I say per, I just mean there's a division line there. So we need seconds per day. So if I start with 60 seconds per minute, do I want to get rid of seconds? The answer to that is no. We do not want to get rid of seconds, right? Because seconds, we want it to be at the top of our division line, right? So the thing we want to cancel is going to be minutes. All right, we're going to look at my other conversion factor, and we need minutes to cancel. So if you guys remember, if I have the same units on the top and the bottom, they're going to cancel out, right? So we don't want seconds to cancel, but we do want minutes to cancel. So if I wanted minutes to cancel out, do minutes have to be at the top or the bottom? The answer to that is going to be the top, right? Because right now, minutes are at the bottom, and if I have minutes on top, they're going to cancel. So pick out a good conversion factor where minutes are on top and there's something else on the bottom. If you picked the 60 minutes over 1 hour, you are correct. Now my minutes cancel and I have hours. Am I done yet? I am not. I have seconds per hour right now, and I want seconds per day. So I still need to convert hours to days. Now we have a great conversion factor for that, right? We know how many hours are in a day. There's 24 hours in one day. So here's what you're going to pick. I have hours on the top or on the bottom, right? I have hours right now on the bottom. Where do I need hours to be to get my hours on the bottom to cancel? You said hours on the top. You are correct. So we want a good conversion factor with hours on the top, days on the bottom. So if you're looking at my conversion factors, you should have picked 24 hours being at the top, 1 day at the bottom. So as you can see, all my units canceled except seconds over days, right? Which is the unit up top that we wanted in the first place. So when I do this math, if you guys remember, I'm going to multiply everything at the top, divide by everything on the bottom. In this case, you're only dividing by 1 because you're dividing by 1 3 times. So you're going to divide by 1, which is going to be the same number. So I would do 60 times 24 divided by 1, divided by 1, divided by 1, and I will get 86,400 seconds per day because those are my units that are not crossed out. So this is PAL, and that's how we do PAL. This is your quick PAL warm up for today. So that is how we do that. So let's keep going. Cool. Let's do another problem. So once again, the first step that you're going to do, I want to write down what is my known and what is my unknown, right? Because I'm trying to get from what my known information is to my unknown information. So this problem says you're throwing a pizza party for 15 and figure each person might eat 4 slices of pizza. How much is the pizza going to cost you? This is a great question. So you call up the pizza place and learn that each pizza will cost $14.78 and is cut into 12 slices. You'll tell them you'll call back. How much money is the pizza going to cost you? Which in math terms, cost is dollars per party or just dollars per party. So I would think to myself, what is the information that I've already been given? Right now, I know a couple things, but what I could start with, I know that 12 slices are equal to $14.78. That's something I know. Now, my unknown is how many dollars per party that I'm going to have to spend, right? So, I also know that there's 15 people that are going to be at one party. That's important. And each person, if I have one person, eats 4 slices of pizza. So those are the 2 ways to write that. If I have one person eating 4 slices of pizza, I can write one person over 4 slices or 4 slices over one person. I also know that one pizza is going to cost me $14.78. So here are my conversion units. I also know that I have 12 slices in one pizza. All right. So this is kind of the tricky part. Think back to when you wrote down what is our given information. We can start with a lot of things. However, it would probably be a good idea to start with $14.78 per one pizza. After that, we are going to go from $14.78, so dollars over pizza, and our unknown is dollars per party, right? So my question to you, do we want to cancel out dollars? No, we do not. Dollars is at the top, and I want dollars to stay at the top, so I don't need to cancel out dollars. What then do I need to cancel out in the problem below? I first want to cancel out pizzas, right? So I need a conversion factor that has pizzas in it. However, we don't need to use one pizza equaling 1478 again. We already used that one, right? So you're going to pick a different conversion unit, either 15 persons per party, one person for 4 slices, or 12 slices for one pizza. Which conversion factor would you use to cancel out pizzas? If you said the one pizza over 12 slices, you'd be correct. So you can go ahead, draw your big train track line, right? You got my train track. If I put one pizza over 12 slices, pizza ends up canceling. So now what my units would be, I have dollars per slice of pizza. So I can find out how much it costs me for one slice of pizza. However, is that what we want? No, we want dollars per party, right? So my pizzas are going to end up canceling their units, right? So now I want to get from slices to parties. There's no direct conversion strictly from slices to parties, but what unit can I use to cancel out slices now? If you said 4 slices over one person, you are correct. So I want slices to be at the top, right? Because I want to cancel out slices. Those are not my end units. So I need 4 slices per person. Wonderful. And as you can see, we can keep going on our train track. Slices is going to end up canceling. So this already looks really good. All right. The last thing I would want to do, I have one person. And do I want to calculate how many dollars per person I'm going to need to spend? No, I'm going to need dollars per party, right? So the last thing I want to do, I want dollars per party. That means I want party at the bottom. So I want the party at the bottom, and I want persons up top to cancel out persons, and so I'm left with dollars per party, right? So what conversion factor can I use to cancel out persons? If you said 15 persons per one party, you are correct. So my persons cancel, and I'm left with dollars over parties at the very end. So that's a good way to check I know I've done this correctly because I have dollars per party. Now what I'm going to do, I'm going to multiply everything up top, divide by everything in the bottom. So the way I could put this in my calculator, I do 14.78 times 1 for one pizza, times 4 for 4 slices, and then times 15 for 15 persons. The next thing I'd do, I'd hit my division sign, divide by 1, divide by 12, divide by 1, divide by 1. Will give me my answer. So again, I multiply everything at the top, divide by everything at the bottom. Oh, doesn't look like. Oh, I don't think I can move my screen either. Well, neat. Remember, Miss Younger's bad at math. So, I don't have a calculator on me, so that's what I got for you guys. It will be okay. So, here's the next slide. So you'll have to calculate that, put it on your paper, and I'll check your answer and see what you got. So, my question for you guys, how do you measure matter? How do you measure anything? Well, there's a couple good reasons right here, or good things right here. If I'm counting something, I can say there's a dozen, which means 12. So like, for instance, if I say, go buy me a dozen eggs, I'm buying 12 eggs. $3 for $1 would be another way, or a 6-pack. For mass, I can do something like, this is a pound, 1 pound, 4 ounces, or 57 grams is a good way to do that. For volume, I can measure liters, gallons, pints, or quarts. So I can do the same thing with chemistry. If I ask you for the volume of oxygen gas, the mass of oxygen gas, or how many molecules or particles I have of oxygen gas. The way you're going to do that, you're going to measure all these things using a measurement called a mole. I know it sounds weird, but moles are very important in chemistry. They're also little creatures that live under the ground, so very neat. Cool. So mass of a mole. So do you guys remember how last week we calculated the molar mass? Which just means I added up all the weights of everything in my compound, right? So, for instance, there are 18 grams of H2O in 1 mole. Oh, sorry, I skipped ahead. The molar mass of a compound is equal to 1 mole. So if I ask for the molar mass of H2O, and you're going to calculate it, and you say, okay, I have 2 hydrogens, each with 1 pound, each with 1 gram, right? So I have 1 gram, 2 grams. Oxygen has 16 grams, so I'm going to do 2 plus 16 is 18 grams, right? So for H2O, there are 18 grams of H2O in 1 mole. So again, the molar mass is equal to 1 mole of my compound. They can be written below. So I can either put moles over the molar mass or molar mass over the mole for my conversion factors. The reason being, right, is because my molar mass is equal to my mole. So it's not always going to be the same molar mass, right? If I ask you for the molar mass of H2O, you're going to calculate it's 18 grams in 1 mole. If I ask you for the molar mass of 1 piece of aluminum, aluminum has a mass of about 27 grams. So for aluminum, 27 grams equals 1 mole. It doesn't really matter. All that matters is that the molar mass is equal to 1 mole for everything. You just have to calculate different molar masses. Wonderful. All right. We can also calculate how many particles are in 1 mole. This is called Avogadro's number. So remember how I told you atoms are very, very tiny. We have our electrons, our protons, our neutrons, and we got a whole bunch of atoms just floating out in space, right? Well, my atoms are very, very tiny, but we actually have a way to calculate, for instance, the amount of oxygen molecules in the air in this room. Crazy stuff. 1 mole, right? We always use our moles. They're very important. 1 mole, this is an extremely important number to remember. 1 mole equals 6.02 times 10 to the 23rd particles. And if you remember back to August or September, I had you write this number out in scientific notation with all the zeros. So this means this number would be 602 with 20 zeros after it. It is a huge number, but that makes sense because our oxygen molecules, you cannot see them with your eyeballs. They're super, super small, right? So 1 mole equals 6.02 times 10 to the 23rd particles. This is called Avogadro's number. Very, very important. So, what is representative of a particle? Well, I could either call it an atom. This is just a particle, and it's just an atom. This could be a molecule. So this could be, let me explain it this way. An atom is just your things on your periodic table all by themselves. Now that normally doesn't happen. Usually they form molecules, which means your compounds bind together with something else, right? So your molecule, you have at least 2 things. Your atom, it's just a simple thing. So it can be an atom, molecule, or a formula unit, but I am not going to talk about those very often. I'm going to mostly reference if I ask you how many atoms of oxygen I have or how many molecules of oxygen gas I have. Awesome. There we go. So here's how we're going to do this. You're going to convert from moles to particles. Very fun. Just like just like 1 dozen equals 12 eggs, It's really the same thing, they just have big words. So for moles and particles, remember 1 mole equals 6.02 times 10 to the 23rd particles. Therefore, write down these conversion factors. My conversion factors will be 1 mole divided by 6.02 times 10 to the 23rd, or 6.02 times 10 to the 23rd over 1 mole. You can write it either way. They are equivalent. So I'll give you a second to go ahead and write those down. Feel free to pause the video if you need to and start it back up. Alrighty, so we're going to do an example problem right off the bat, right? So this is basic PAL. We are going to be using PAL for all these problems, and I promise you this makes life a lot easier. And this is why I said that at the beginning of the year, you aren't going to be able to just do stuff in your head. This is why I made you use PAL, so that at this stage in the game, you will have to use PAL because it's going to get very complicated, and you are going to want to use your PAL. It makes things a lot easier. So my question is, how many moles are in the number of molecules? So we're going from moles to molecules or molecules to moles. My sample problem, I have 1.25 times 10 to the 23rd atoms of magnesium. My question is, how many moles is this, right? So basically, how many moles are in 1.25 times 10 to the 23rd atoms of magnesium? First, this looks complicated, but I promise you guys will catch on so quick. First, you're going to write down your known and your unknown. So your known is what's given to you in the problem, the 1.25 times 10 to the 23rd atoms of magnesium. Now write down what is unknown. What are you trying to get to? And the answer is moles. My unknown is going to be moles. So I'm trying to get from atoms to moles. Simple as that. So we're going to determine the conversion factors that are needed, right? The things that are equal to each other. So we do know Okay, so your conversion factors, we do know that 6.02 times 10 to the 23rd atoms are equal to 1 mole. That means my conversion factors would be 6.02 times 10 to the 23rd over 1 mole, or you'd have 1 mole divided by 6.02 times 10 to the 23rd. Either way, you just need 6.02 times 10 to the 23rd on the top and then 1 on the bottom. And those are my conversion factors, right? Because that will get me from particles to moles. So the first thing we want to start, this is step 3, multiply the known by the appropriate conversion factors so units cancel. So the first thing I'm going to start with is my known. I'm going to put it in the top left corner of my train track always. So my known is 1.25 times 10 to the 23rd atoms of magnesium. I'm going to put it in the top left. Oh, does it not? Did it not? Did it? Okay, very neat. Sorry guys, it didn't play the, well, anyways, you need to write this down. So you're going to have 1.25 times 10 to the 23rd atoms. And then in the very top left corner, you're going to draw your train track. So go ahead and do that. Your conversion factors should already be written down. I told you them. So you're going to look at your 2 conversion factors, right? What unit do we want to cancel out? The correct answer is atoms. We want our atoms to cancel out. So if I want my atoms to cancel out, I have 1.25 times 10 to the 23rd up top right now. If I want atoms to cancel out, I have to put atoms on the bottom. So on the bottom, that square on the bottom, I'm going to put 6.02 times 10 to the 23rd. And that is equal to 1 mole. So I can put 1 mole at the top next to 1.25 times 10 to the 23rd. However, your atoms need to be like diagonal to each other. Don't put them up and down. They need to be diagonal to one another. So moles need to go on top, and 6.02 times 10 to the 23rd needs to be on the bottom. After I have that written out, my atoms will cancel and I'll be left with moles. which is perfect. Aha, here's my work. We just did it backwards. So here's how this should look. I have my conversion factors. My atoms are going to cancel. I'm left with moles. So when I calculate my answer, when I multiply everything on the top divided by everything at the bottom, I get 0.208 moles. So go ahead, pause this if you need to. Make sure you have this written down. Make sure you know how to do it. If at this point you are like, Coach, I have no idea how to do this based on what you are telling me in this video, raise your hand and I will come explain it to you in person because I think that will help as well. Wonderful. So we're going to go ahead and move on. You feel free to pause this video. All right. The second problem, how many molecules are in 2.0 moles? Wonderful. Step one, we're going to write down what's our known and what's our unknown. So our known in this video, what did they give us in the problem, right? What did they give us? They gave us 2.0 moles. So that is our known. I know that I have 2 moles, right? My unknown is molecules. All right, the second thing I want to do, write down my conversion factors. So again, write down my 2 conversion factors for moles and molecules, right? I need both of them because they're going to, I need both of them because it's different on which one you use based on the problem, right? So my conversion factors would be 6.02 times 10 to the 23 divided by 1 mole, or I have 1 mole divided by 6.02 times 10 to the 23rd. Cool. So you are going to take your known information, put it at the top left. So I will have 2 moles at the top left because that's my known information. Now you're going to look at your conversion factors and say, okay, what do I want to cancel? I want to cancel moles, right? Because I want molecules at the top all by itself so that I'm left with molecules, my unknown. So use the conversion factors that has moles on the bottom and molecules at the top. That's how this should look. You should have 1 mole on the bottom, 6.02 times 10 to the 23rd molecules at the top so that moles cancel and I'm left with molecules. Again, I would multiply 2 times 6.02 times 10 to the 23rd, and you would divide that by 1 mole. Please go ahead, put this in your calculator. Make sure you know how to do this so that when you get to a test, you know how to put it in your calculator. Cool. And I have 1.20 times 10 to the 24th molecules is my final answer. So make sure you got that answer. Make sure you check your answer. Make sure you put it in the calculator right. If you're confused, raise your hand. I will come and help. Awesome. All right, here's another problem. How many moles are in 6.02 times 10 to the 23rd particles? So what is my known information? What did they give me in the problem, right? It is 6.02 times 10 to the 23rd. That's my known. My unknown are moles. That's what I'm trying to get to. So I have my known, and I'm going to put my known in the top left corner every single time. Beautiful. Now, think back to your 2 conversion factors for moles to particles. Do I need particles on the bottom or the top? I need particles on the bottom, right? So that particles cancel out and I'm left with moles. And we know that 6.02 times 10 to the 23rd particles equals 1 mole. So I'm going to put that as my conversion factor. Since they're equal to each other, I can put them on top of one another, and I'm left with moles at the very end. Awesome, guys. What would this answer be? You should be able to do this one without a calculator. Aha! You got 1 mole, right? Because... Oh, my recording is going to end, so I'm going to make this 2 different videos. Sorry about that, guys. Thank